just to review, starting with the ring structure of glucose. I promise to send the pictures of the chain structure of glucose, and then now you'll understand why we get to a ring structure. So the ring structure of glucose here is, as you can see it, carbon I listed carbon 1, 2, 3, 4, and 5, and based on the position of the OH molecule on carbon 1, that's why it's termed alpha glucose, because OH is at the lower end of carbon 1. So for beta glucose now, notice the OH is at the top of carbon 1. So once the OH is on the top of carbon 1 for glucose, it's going to be termed a beta glucose. Alright, so alpha glucose, OH is at the bottom. Beta glucose, OH is at the top. Alright, now for fructose has a different structure, and how we determine whether it's beta or alpha is the position of carbon 1 in respect to carbon 2. So once carbon 1 is at the top, then it is beta fructose. And the second one, once carbon 1 is down below, then it is alpha fructose. So alpha fructose, carbon 1 is lower compared we could say inferior to carbon 2, and once carbon 1 is superior to carbon 2, then it is beta fructose. Alright, so now to the disaccharides. So now we're going to look at the bond between two alpha glucose molecules. So notice I have not included the numbering of the carbon atoms, but you would remember that this is carbon 1, 2, 3, 4, 5, and 6. And this is same thing over here, carbon 1, 2, 3, 4, 5, and 6. So what is going to happen here is what we call a condensation reaction. And the condensation reaction is going to take place between carbon 1 in the first alpha glucose and carbon 4 in the second alpha glucose. So that condensation reaction means that we're going to remove a water molecule, as you can see right here, and that removal of a water molecule going to equal to this bond being formed here with this oxygen molecule left behind. That bond is now going to be called a glycosidic bond. Good. So the 1,4-glycosidic bond and the molecule, the disaccharide that is formed now, is going to be called maltose. So maltose is made up of two alpha glucose molecules. Another disaccharide would be alpha glucose molecule bonded to a beta fructose molecule. And why we say it's a beta fructose, remember carbon 1 is all the way up there at the top, and there's carbon 2. So once carbon 1 is superior to carbon 2, then we know that this molecule is a beta fructose. So the bond is going to take place between carbon 1 and carbon 2 of the beta fructose. So the condensation reaction will occur, we'll lose water, and then we're going to form a glycosidic bond. The glycosidic bond down here now is going to be called, alright, so the bond is going to be called alpha 1 beta 2 glycosidic bond. Alpha 1 from the carbon 1 from alpha glucose, beta 2 carbon 2 from the beta fructose, glycosidic bond. The molecule is called sucrose. Good. So if you review two disaccharides we looked at, one is maltose, formed from two alpha glucose molecule, do condensation reaction, and you get a alpha 1,4-glycosidic bond. Down for this one down here, it's a bond between the alpha glucose carbon 1 and the beta fructose carbon 2. So we have an alpha 1 beta 2 glycosidic bond, and that molecule is called sucrose. Alright, so we looked at monosaccharides now, and we looked at disaccharides, and now we move into polysaccharides. First thing with polysaccharides, I want you to understand that this is a extra long. I'm just being extra when I say that. Extra long. These are large units of glucose. To be even more, and extra again, we say it's made up of thousands of glucose units. So I'm going to give you an example. An example of a polysaccharide is amylose. Now, polysaccharides are really polymers. Polymers are large carbohydrate units, are large molecules then, not carbohydrates alone. Large units, large biomolecules. Good. So the monomer would be the unit that makes it up. So when you break down a polysaccharide, you break it all the way down to its basic unit. We call it a monomer, right? So monomer, monosaccharide, polymer, polysaccharide. Now amylose is made of alpha glucose exclusively. So what you will see is, this is the bone structure, just the very basic, is alpha glucose, alpha glucose, alpha glucose. Wonder what kind of bond this would be. Glycosidic 1,4 alpha 1,4 glycosidic bond, alpha 1,4 glycosidic bond. Now this goes on, this continues for thousands and thousands and thousands of chain linkages. So thousands and thousands and thousands of linkages. Actually it goes into a spiral or a helical form. So in nature, amylose exists in this helical shape like a spring, because if so many glucose units, it's not going to be a long continuous chain. It's actually going to spiral into a shape looking like this, right? So that's what amylose is, made up of exclusively alpha glucose molecules, and the glycosidic bonds are alpha 1,4 glycosidic bonds. All right, so we have amylose. Now there's a second example of a polysaccharide. We call that one glycogen. Now how glycogen exists is that there are going to be branches of each. So let me show you how the branches come about first. So remember we have carbon 6 up here, and remember we always write carbon 6 with H2O, H2 and OH. Good. Now what you can have happening is carbon 1 from a new chain is going to be bonded right here to this, form a glycosidic bond right here. Good. With the carbon 6 and carbon 1. So you have another chain branching off going along. So that chain would branch and curl just like what you see I have it right here. So the branch that you see right here is just another chain of alpha glucose bonded to the carbon 6 of one of these from the amylose. So originally of the amylose having the helical structure like that, but from the carbon 6, which is, see a carbon 6 would be here as well and another one here. So what you can have happening is that another chain of amylose of alpha glucose just bond off. We just draw it like this. Now when you have amylose with the branches, this bond here would be a glycosidic, but it'd be a 1,6 because it is carbon 6 here, carbon 1 for the chain, but carbon 6 here. So it'd be a 1,6 glycosidic bond. So generally, structure of glycogen. So glycogen is another polysaccharide, and that polysaccharide is basically of the amylose. It's all made up of alpha glucose, but remember within this glycogen molecule you're going to have a lot of branches on it. Good. So glycogen is made up of both alpha 1,4 glycosidic bonds and alpha 1,6 glycosidic bonds, because the 1,6 bonds are the branches, the 1,4 bonds are the helical things like this. In amylose, you only have alpha 1,4 glycosidic bonds.